Hi, my name's Craig Manzinger. I'm an applications engineer here at OKUMA America. I've been working here for about 5 years now, and I focus primarily on the lathes and especially the high-tech line like our Multis machine. A lot of people go to concerts, a lot of people are fans of music of some sort or another, so the guitar is easily recognizable to people that may not be familiar with manufacturing otherwise. A big part of the challenge, other than the designs such as the Z-Glide on the back and patterns and the engraving, which really pop off the part. So we have a large piece of stock that we machine probably more than 90% of it away. On one side of the neck, you may remove almost all the material, and on the other side, it's very close to the surface of your raw material. There is a lot of stresses in the material normally. As you start to remove material, especially in the roughing cycles, the material naturally is going to want to bow and bend, and we're using technology that's on the control to sense that, and we can watch the load of the servos, and before we do every single cut, we do a very consistent gentle push of the material and then a gentle pull so that we're always keeping the material in the same state. The surface finish on this guitar is going to be critical. This is something that is going to be a work of art. It needs to match all of Dean Zielinski's other works of art that he's created. So we have software called Hypersurface, and that's just the latest iteration of our smoothing software. And we end up with a very nice, almost polished looking surface for both our engraving and our contours. One of the challenges we found when we were roughing our stock down is as we were cutting on it, we were using a tool pass strategy that kind of put equal loads along the part and down into the part. And we were able to use the OptiRough out of Mastercam to put a lot more side load on the tool, which then actually directed all the loads towards the chuck instead of into the workpiece. Switching from the initial tool path we had to using the OptiRough toolpath was very straightforward, and that quieted right down, and we were actually able to remove a lot more material quicker and quieter. As we've been going through the tooling, there was a lot of planning ahead of time with the whole group, and it was done very well. We did run into some cases where we wanted either more or less flutes on the tools, or maybe a little more corner radius as we were cutting the part, and Iskar right away jumped in, next day us some tools, and we were able to just keep on going without any hiccups. We also have 12,000 RPM on our machine, which works great for all of our tools until we get down to our 2mm ball nose end mill. We can still run it at 12,000, but the parameters are asking for tens of thousands of RPM. One of the really cool tools we're using from our partner Iskar is the spin jet. And it's similar to an air spindle, which you may be familiar with, but we're using high pressure coolant, and it allows us to run up to 40,000 RPM. Another benefit of the spin jet over an air spindle is coolant is a lot more dense as a liquid. It's a lot more dense than air is. So instead of a large bulky air spindle, which could lead to a lot of clearance issues, we have something that's about 1.25 inch diameter. It's metal 3D printed, which is really cool, and has a coolant nozzle that blasts it right on the tip of your tool. So you're not only spinning your tool, but you're keeping it cool, and it's directed right to the right spot. Throughout my career in machining, I've made a lot of cool parts, but it is really sweet to be able to make something that is going to be played as a musical instrument. I'm really looking forward to somebody making some notes with this thing.